Okay. So for the warm-up here, you're just supposed to answer whether it's true or false, just kind of looking at that reasoning piece to begin with. The first statement says, if an object is red, then it's not blue. If it's red, then it's not blue. That would be true. And then what you'll see is like they're taking the same types of statements and they're rearranging them. And then you realize like if you rearrange the order, sometimes it's false. So if an object is not red, then it is not blue. Well, it could be blue. So that is false. 3, if an object is not blue, then it is not red. Well, it could be red. So that is false. And 4, if an object is blue, then it is not red. That is true. Okay, then number 5 kind of is a precursor into what we're doing today. It says rewrite the statement as a true if-then statement, and it gives us the statement an even number is divisible by 2. So what it means is it wants you to say, okay, if you have an even number, then it's divisible by 2. Or if a number is even, it's divisible by 2. So we'll do that. If a number is even, then it is divisible. Oh, I'm running out of room there. That's supposed to say divisible. Divisible by 2. So what we have here is the if-then statement it was looking for. We have the if and then. This right here, the first part, is called a hypothesis. And the abbreviation for hypothesis, which may not mean, like, is P. I don't know why they use P. I don't know if it's like a Latin word or something that starts with P, but hypothesis is P. And then the second part, this part, is called the conclusion. And the conclusion is Q. Don't ask me why. I don't know. Okay, so we have the first part, hypothesis, then its conclusion. So we took this statement and we made it more like causative effect. If a number is even, then it's divisible by 2. Okay, this box right here, I'm going to explain it, but I feel like this is too wordy and too much to look at. So this box, just cross it out, and I'm going to do a shortened version on the other side. Okay, then over here, so like in this top part, we're going to make a quick note. So we're going to do if-then statements, like we just saw. So the structure for this is if hypothesis, then conclusion, and hypothesis is abbreviated as P, and then conclusion is Q. So P, then Q is the abbreviation that you'll see. And then this is also called a conditional statement. If-then statements, also known as conditional statements. If hypothesis, then conclusion, and hypothesis is abbreviated as P, conclusions abbreviated as Q, and then this statement right here means P, then Q. Okay, so down here, example 1, it says identify the hypothesis and conclusion of each conditional statement. So here it says if a polygon has 6 sides, then it is a hexagon. So this right here is the hypothesis, the P, and then this is the Q. Hypothesis is P, conclusion is Q. So our hypothesis is if a polygon has 6 sides, conclusion, then it is a hexagon. Oh, if you click off the tab, here, I'll fix it. Let me apply. Just like if you click another tab, that happens sometimes. So try to stay on there, choose an action, unlock. Okay, and let me see if Jorge's on there too. Oh, Jorge's not. Did you find him? Oh, it's on. And then the password's right here, Jorge. Okay. Okay, the next one is similar. The difference is they kind of switched out the order, but the hypothesis is always that if statement, if P, then Q is the conclusion. So, oh, thank you for letting me know. Okay, so hypothesis is if P, and then conclusion is then Q. In this statement, it says another performance will be scheduled if the first one is sold out. So in this one, the if statement is actually over here. So if P, then Q is over here. So if P would be if the first one is sold out, then another performance will be scheduled. Okay, and then the next one, they go back to the regular if then in order. So if P, then Q. The hypothesis would be this first part if the forecast is rain. Then I will take an umbrella. So if P, then Q. And this example here, they switched up that order again. If is right here. If the last digit is 0, then a number is divisible by 10. So this is the if P. So hypothesis is if its last digit is a 0, then a number is divisible by 10. Example 2 down here, we're just going to cross it out. Just cross it out. Down here, I'm going to make a little like notes or like vocabulary that we need to know. And these two words are statement, and negation. Okay, so a statement, I'm just going to give you an example, would be like the folder is red. There's a statement. The negation for that would be the folder is not red. The folder is not red. So it's like the opposite. So if the folder is red, the negation would be the folder is not red. The statement could also have not in it. So let's say it said the statement is the folder is not red, then the negation would be the folder is red. So it's just like opposite. And then also there is a symbol for negation and it's a squiggly line like this. So this means not. Or the opposite. Okay, and there's some good practice with Alex for this next week, and those will post tomorrow morning. So if you want extra practice with that specific skill, that's on Alex for next week. Okay, and then how does this relate to what we're doing on the other page? We're going to move up to the top of the next page. On this side, I'm going to have you do some more notes, but it's going to take up some of the space. So like cross this out because we're not doing this example, and we're also not doing this example. So you can use this room to write down what we're about to write. So cross this out here. Here, would it be easier if we saw the whole page? Okay. So I crossed off everything but we're going to do example 3 when we get there. So I crossed off this, but don't cross off example 3 because we're going to do that one. Okay, so in this area right here, we're going to look at 4 things. We're going to look at conditional statements, converse, so leave yourself some space, converse, inverse, and contrapositive. Okay, so conditional, and I'm going to use symbols, is P, then Q. So if P, then Q. And usually you'll have an original statement. If a number is even, then it is divisible by 2. The converse is Q, then P. So you'd take these statements and you just put them in another order, and you'd say, okay, if Q, then P. So we said if a number is even, it's divisible by 2. You could also say if a number is divisible by 2, then it is even, and you just change the order of those statements. And then inverse, you take the conditional and you say not P, then not Q. If not P, then not Q. So if your number is not even, then it's not divisible by 2. And then last but not least is contrapositive. And that would be taking the converse and saying, okay, not Q, then not P. If not Q, then not P. Okay, so how do we use this stuff? This is something you're going to want to reference, and also this isn't on any like reference sheet or anything, and I promise you it'll be on the EOC and like your benchmark assessment. So you have to have like conditionals P then Q, converse Q then P, inverse not P then not Q, and contrapositive this memorized in your brain, or you have to be able to like write it out on a piece of paper if you need it. So just to let you know. So as you're doing this, like kind of commit it to memory as you're practicing. Okay, so then example 3 down here, I'm going to kind of cut out some of the wordiness here, and it says, write a converse, inverse, and contrapositive of the true conditional statement, tangs are fish that live in salt water. So our original statement is, tangs are fish that live in salt water. And based on that original, we're going to make a conditional, which conditional is P then Q. And then we're going to make the converse, which is Q then P. We're not going to use this here, so I'm just going to cross that out. And then we're going to make an inverse, which is not P, then not Q, and a contrapositive. Not Q, then not P. Okay, so based on our original, tangs are fish that live in salt water. Our if-then statement would be if a fish is a tang, then it lives in salt water. If a fish is a tang, then it lives in salt water. So this here would be our P, and then this second statement would be our Q. It'd be helpful if I zoomed in a little bit more too. Okay, then the converse is Q then P. So what I have to do is just switch the order. I'm going to say if a fish lives in salt water, then it's a tang. If a fish lives in salt water, then it's a fang. Another thing it asks us to do is just determine whether these are true or false. If a fish is a tang, then it lives in salt water. That's true because all tangs live in salt water. But the next statement, if a fish lives in salt water, then it's a tang. There's a lot of fish that live in salt water, and they aren't all tangs. So this one is false. Then inverse, not P, not Q. So what we're going to do is go up to our conditional and just use this statement, but put not P, not Q. So if a fish is not a tang, then it does not live in salt water. If a fish is not a tang, then it doesn't live in salt water. Well, that's not true either because a lot of fish live in salt water, not just tangs. So that is false. And contrapositive, not Q, then not P. So I'm going to go to the converse, which is Q, then P, and just put not in it. If a fish does not live in salt water, then it's not a tang. If a fish does not live in salt water, then it's not a tang. That is true, because tangs only live in salt water. So this last statement comes out to be true. And again, you'll have your homework on this. There's also some good practice on Alex for next week too. And then we're going to flip to the next page. We're almost done. We have like 2 minutes left. The next part's really short. Okay, the next concept is called biconditional statement. And we're not doing this whole page. We're only doing one example here, just so you know. A biconditional statement is a conjunction of a conditional and its converse. And its converse. So what we're going to write up at the top is like notes. If the conditional statement, like conditional and its converse are both true, then a biconditional statement can be written. Biconditional statement can be made. The key to a biconditional statement is it'll say if and only if. And we'll see an example. Okay, and then over here, we're going to do this example right here. It says write a conditional and a converse for the statement and determine their truth values. If false, find a counterexample or write a biconditional statement if possible. So our statement right here, it says isosceles triangles have at least 2 congruent sides. So we're going to make this into a P then Q for the conditional. If a triangle is isosceles, then it has at least 2 congruent sides. So this is our P then Q. Conditional is P then Q. converse is Q, then P. So we just are going to switch the order. So we're going to take Q and put it first. If a triangle has two congruent sides, then it is isosceles. If a triangle has two congruent sides, then it's isosceles. Trying to abbreviate as much as possible. Okay, and then we have to determine if these are both true. If a triangle is isosceles, then it has two congruent sides. That is true. If a triangle has two congruent sides, then it's isosceles. That is also true. So since these are both true, we can make a biconditional. And the biconditional would look like this. It would say a triangle is isosceles if and only if, remember that's that key statement for biconditional, it has at least two congruent sides. And that is all. Okay, so now you have the last 20 minutes to get your homework done on Schoology and then work on ALEKS. If you have 8 or more ALEKS done, then you can help one person with an assignment and then get your phone. So here is your to-do list. I'm going to freeze this here. And go ahead and get a computer and get started, and I'll enable the homework.